Good morning and good evening. As discussed in the last video, we will be discussing about one of the critical components of MLflow, which is called MLflow tracking. As shown in the screen, we'll be taking a dataset, which is most common dataset, which is called iris dataset. And using this dataset, we'll be completely going through what the MLflow tracking feature is all about and how it can be utilized for machine learning purposes. So with that introduction, so I have taken this iris dataset, and this iris dataset has got four different features like sepal length, sepal width, petal length and petal width, and along with the target column there are three different targets, Setosa, Versenica and the other one I forgot actually, but yeah, these has got this three targets. So after that, reading the data, I have created one definition or a method which will clean the data, in which it will identify whether there are any unfilled data columns or data fields, and then it will try to eliminate those. And after that, I taken the train test plate from the sklan module, and then using which I'm splitting the data into x train, x test, y train and y test, and the shapes of all these x train, x test, y train and y test are something like this. And then I constructed the basic decision tree classifier. It could be any kind of a classifier because we are dealing ultimately with a classification problem. So it could be k nearest neighbors, or you can even use SVM classifier, or you can use random forest, or any classifier in case, in that case. So but basically I've chosen a decision tree classifier, most basic classification algorithm that we have read in our curriculum. The reason why I named this definition as a basic classification or tree classifier or classification algorithm is I don't have any hyperparameter tuning in this particular classification algorithm. So it is just I pass the x train and y train, and then finally I would fit that and get a model out of it. So I'm not doing any kind of a tuning there. So that's the reason it is called the most basic model that I'm building, and that's the reason. And the name of the method is also most intuitive. And once I get the model, so I've written three different definitions, like to get the prediction by passing the x test, and to find the prediction probabilities by passing the x test, and ultimately generating the metrics like accuracy, precision and recall. So if you see that, I computed the y prediction, y predicted probability, and then finally over the generate metric, so I have an accuracy of 96 of everything, like accuracy is 96, precision and things like this. And then till here, whatever you see, it's like plain machine learning algorithms, plain machine learning model training, and then evaluation things. So here what the MLflow exactly starts. So I've just declared few of the global variables, like what is the experiment name. My experiment name is the basic decision tree classifier. And then what is your run name. Run name is the experiment, which is like iris flower classification, and then run metrics. So I have some run metrics, right? So those run metrics. And then now I defined one method which takes the experiment name, run metrics, your model and run parameters, and then tag. You can tag this. So if you see my previous video on MLflow, I've shown the basic tracking feature, how that looks like, and then how the tagging works and all. So if you didn't watch that, or don't understand what exactly is this model parameters and all, so please go watch that video and come back here, such that you have a more better understanding. Okay, so we take the tracking URL, which is the custom URL that I'll be showing what is this tracking URL all about. And then we'll pass all these, and then finally we'll log the different parameters that we pass, like logging the parameters, logging the metrics, and then finally we log the model, and then we'll set the tags. You call this particular method with all the required parameters, and that would be done. And very similar to this, now what I've done is, since we have the basic model, we should also have the advanced model as well. What do I mean by the advanced model is, like, you can actually train the model with some hyperparameter tunings. So I just created this parameter dictionary, like what is your criteria. So my criteria could be like Gini, entropy, or log loss, and then splitter. How do you want to split it? So you want to go by the best split or a random split. So how many number of maximum number of trees depth, because decision tree classifier is all about trees. So what is the depth of those trees? So I just went with none, so no depth, and then 5, 10, 15, some random numbers, and then classification weight. So how do you balance the trees with respect to the class weights? So you don't want to balance it none, or you just need to have some balance. So all these are my hyperparameter. There could be many else as well, but I just chosen four of them, which I felt like, okay, if I can tune over this, then I could get the best model. So now to do the best model choosing, so I've used something called gridset CV. uh, Basically, grid search CV is nothing but it's an algorithm which will do a permutation and combination of all these things. So first of all, it'll try to train your model using Gini best none and none, and then Gini random 5 none and something, all. So all different permutation combination of your parameter dictionary would be done in this algorithm, and then finally it will arrive at a best model with the selected parameters that are passed into that particular model, and then that would be shown here. So I've trained it, and then I've called this particular model, and if you see, this class weight is balanced, criteria is Gini, max depth is 5, and splitter is random. So if you pass this as this, and then I'm getting an accuracy of 0.97, so that is 97% of accuracy. So if you want to do it manually, then you have to play with this multiple times with multiple permutation and combinations. But grid search CV is one such algorithm from sklearn. It will help you to lower the code base, and then get you the best combination of the parameters. And ultimately, again, I pass all these things into my start experiment to track the optimized tree classifier. So I again declare the experiment name, which is like optimized, and then classification would be the same thing, iris only, and then the metrics change here. So, and again, I'll pass all those things into the start experiment. So what I want to show is now, so we'll start the UI by calling something called MLFlow UI, and then you pass the host name and the port name as a switch, we call. So MLFlow UI hyphen host 127.0.0.1, which is the loopback URL, or the local host URL, and the port is 3000. So once I run it, so it will generate something called ML runs. So if you see, there is nothing here, there is nothing here. So it creates a local directory which is called file system based tracking mechanism. So it is one of the tracking mechanisms of MLFlow. There is another way of tracking also, which is called MLFlow backend integrated tracking system. So I'll show both of them. So first we will see how the file system integrated tracking would work. So now you saw that server is running in my terminal, and let me run whole notebook and then check how it works. Okay, so now the notebook has been run successfully, and if you go here, there is I think let me refresh, reload. So okay, now the artifacts has been created, and there are a lot of runs got created, like basically a lot of means like 2 runs, because one for the optimized, one for the basic. And once you have all these runs, you can host the UI. So 127.0.0.1 which is the tracking UI. So once you launch it, this is how it looks like. Just refresh it. So it took both the runs from the file based tracking, which is our ML runs folder, and if you just click on it, it traced the run name, because this is the run name that you have given for the start experiment method. So if you click on it, so if you see this model has been recorded the tags, optimized decision tree tag has been recorded. Metrics are this, like now I in this particular run I have got 98% of accuracy, and then there are no the parameters are not too much, but yeah, all the parameters which we used for optimizing, so those are recorded. And finally there is no description as well, so as such you can put that. But yeah, so this is how everything is tracked. But now there is a question: what happens by mistakenly if this ml runs or the ml artifacts is deleted? Because this is all on file system tracking, right? So there is always a threat that these folders can be deleted accidentally. So that means your tracking is gone. So in this particular scenario, the other methodology of tracking would come to help in very strongly, which is like MLflow server integrated to a backend tracking system. So that I'll show you now. So what I'll do is let me bring up my terminal, and then I'll stop this. So let me stop this. So I stopped this, and I'll try to delete both of these folders, and let me open up again and then say MLflow run. Okay, and for just confirmation purpose, I just wanted to show you guys that yes, we really deleted that, and then our UI looks clean, so there is nothing now. So this is what I was talking about. So accidentally if someone goes and deletes, then your history is gone. So now what we do is we'll try to integrate this with our backend is basically I have my Postgres database installed in local. So what I'll try to do is I'll integrate MLflow server with the Postgres database. So that means like whatever the experiments that we are tracking in MLflow, those gets recorded inside the Postgres, such that like they are permanently persisted, so you can check it at any point of time. So for which like I just need to change the command a little bit. So what I'll do is I'll stop the basic server. So this is the basic server running. So now to integrate MLflow UI server with the backend, so there is a different little bit a change in the command, which one extra switch that gets added, which is called backend store URI. Okay, so let me run that MLflow MLflow server, MLflow server backend store URI, and I have my Postgres URL running at this, and I have my database which is called MLflow. And again, all this thing, default artifact would be your .ml runs, which will be created in the current folder, very similar to what we did it in the basic flow or the basic run. And then same thing again, you pass the host and the port. So with this let me run this. Okay, it's running, up and running, no issues, no errors. So just let me put it down, and now let me take the help of the database connected. So if you see it here, so my MLflow Postgres database got connected, and you see all these tables got created by the MLflow, and I've tested with couple of runs even previously. So what we will do is now we'll host the URL and then check how it looks like now. So let's delete, and then okay, now see this. So you have the basic decision tree classifier, optimized decision tree classifier, and you have number of runs, maybe like 1 hour back, 3 days ago, and all these things. From where we are getting everything from the backend database. Okay, just to give you a confidence that these are literally coming from the backend database, let me run our classification algorithm again, and then see like where all these data gets recorded, and then how it looks like in our UI again. Okay, so let's run this notebook again, and then see what happens. Okay, now notebook got finished, and let's see now. So before I refresh the screen, there are 3 runs that are happened. So let me refresh and see. Now there is a 4th run that has happened, which is like 13 seconds again, which took like 1.6 seconds. And now what we will do is we'll see where are these metrics getting tracked inside a database. Now it is all same. So if you click this, like all this would be the same, but all this data is coming from a database, so we just need to identify which all tables are involved in getting these data from the database, right? So minimize this. Now go here. So there are runs here, right? So let us open a new SQL console, and then we'll say select star from runs order by, I don't know which columns are there, experiment ID, start time, order by start time, descending, so the latest would be on the top. Okay, so this one. Okay, so now we have the data, but the start time I'm seeing it in the epoch time. So let's copy this, let's go for the epoch converter and then see what is the time. Okay, see this, Tuesday, 11th April, 8:53. Now it is 8:55, so yeah, just 2 minutes back we have run that. So that means it's been recorded, so uh, into the database. So we have a lot of things. So you have runs, so every run has got their unique ID, and then you have experiments. So let's see experiments also. Select star from um, experiments, and then where run, I think like run UID should be there. No, let's see how the table structure would look like, and then select star from experiments. Yeah, this is what the experiments are like. We have only the experiment IDs. Okay, so basically this is how the ML tracking works. So you have experiment, the actual experiment. When I say experiment, the machine learning algorithms, and then all the logics, and then the pre-cleaning processes of that, and then you can actually integrate that particular experiment tracking in two different ways. Either you can follow the file based tracking mechanism, or the backend based tracking mechanism, where my backend is PostgreSQL, and you can integrate to any other database as well. We'll provide the links in the description, how you can integrate and all. Yeah, but this is how the one of the concepts of ML flows, which is like ML flow tracking would work. Looking forward for the next lectures in the series, like how the ML flow registry, ML flow model would work, coming soon. And stay tuned. Please subscribe, like and share if you like this content. Thank you.